just turn it off. I put the chat on. Someone start. Perfect. Thanks. Nope. Okay, I will not monitor the chat then. So yes, it's a big chapters. I don't know if I will try to cover everything, but if we have like some question or if we want to delve into an exercise, I think it's worth doing it instead of maybe checking everything. So as you like. So the chapters is intituled Vectors, and I think it's kind of weird in plenty of way. I will try to explain myself because like we're gonna start seeing like some what's Hadley called scalar, which is in other like CS computer science course, you will maybe think they're also like data type or atomic type. And then we're gonna try to generalize this atomic type in vectors, then in lists, then in a specific kind of structured list, which is called a data frame, another kind of structured list that's called a table. And we also make a small sideway to S3 S3 I don't know you call that. I'm going to call that object, but it's more broad than that. So it's a very big chapters and it's cover a lot of grounds. So the learning objective is learning like the different type of vectors. It's not just the atomic type, but the tip you build from the atomic type. See how they are used also like to build more complex type. And we should discuss like one of the important type for R, which is data frame and tables. I'm not, it's more a class than a type, but I will keep it like that. We will still view NA and null, but it's very fast, I feel. Okay, I don't go too much into that. The package that are used are here. So Derek was nice building this aperitif, but I think I will not have time to do it today, Derek, sorry. It's just a small test, like if I don't know if everyone is familiar with the Palmer Penguin dataset, but basically here, like you can try to count all the Gen 2 into this dataset. But if you extract one column, in fact, you don't exactly extract one column and try to see how many Gen 2 are inside of this column, it's not working. So Derek just fix it and show you like what kind of object you get instead. And it does that in multiple ways. Oops. And that generates the question about the different type of vectors and how we can access it. So we have 2 and maybe 3 basic type. Null, we're gonna keep it at the end. Atomic and list. A list is built on top of atomic. And we can have, sorry. And in the case of atomic, all the elements are the same types. I think we're gonna review that just after. Yes, sure. And lists can have multiple type. And the null elements are specific, and I mean it's not often. They should be length 0. And this is how it's built. So we have the logical, true, false, integers and doubles. Both integers and double will make what are called numeric, and we have character, which is more classic. And all of them are atomic, and all of them can generate vectors. I already gave some example. I think it's better if we look at one. So scalar are vectors that consist of a single value. This is more like a theoretical definition because R does not identify scalars. It's just vector of length 1. Blah, blah. So some example of logical. I'm never too sure of using T and F as an abbreviation of true and false. I think it makes the code harder to read, just a matter of test. So I think if you can and also the linter will not necessarily recognize them. So I think you should avoid line 2 and line 4. Doubles, there's plenty of way of writing doubles. by default 1 will be a double, and you can specify like 1.0 sometimes make more sense, or you can write in scientific format also as you like. Integers, you should add the L if you want to specify it. The pop quiz is L is because I was not very readable from 1. I don't know why exactly after that I'll make it more readable. String is classic, nothing to matters. We are not gonna go too much into like this double quote and single quotes. I will not remember by head, so you should look at it by the in our console, like just slash question quotes will tell you the difference. I never remember that. I always need to Google it. So the good point is like you can combine them, for example, like with the C function, which combine them and also flatten them. This is very, the most interesting is the line 4, which will generate 2 a vector of flanks 2. The rest are pretty straightforward, I think. You can also combine other vectors, and the C will flatten the structures, unlike what you could expect in some other kind of scenario. There's also a Erlang version of it. I will not go too much into it. They have like subverb for every kind of data type you want. The type of is, I don't remember, I think it's the type equivalent of type in Python, and it's gonna give you like the the type of vector you have. And length is kind of the equivalent of shape. It's gonna tell you like, not exactly, but it's gonna tell you like the length of vectors. For example, like yes, it's given on line 2. Invar will be like a length of 3, starting by 1. Missing value. So missing value are always tricky to play because their behavior can change. So they can either be contagious. I hate while you go back to line. It can be like either like they're contagious, and this one makes sense. If you do 5 times NA, you're gonna have NA because R does not know how to handle it. The same with sum. If you want to sum something that says not defined, it return an NA. I see some question in the chat, maybe. Chats too. Did I miss something? No, we good. So, and there's like exception, and this one, I mean, at least I think the NA, I don't know what you say, power, yeah, power in English, power of 0 make 1, because the power of 0 always make 1. So this one is nice. NA and true, NA or true make true, because like we already, I mean, this is an OR, so we know that it's gonna always be true. And NA and false will always make false, because like 1 is already false. So two exception makes sense in my mind, but like they make sense in my mind when I see them, and I will probably like make easy error with them. Inoculation, yes, you can also decide to remove them, and not a function of NA that remove equal true to remove the NA inside of as an argument. To search for missing value, you shouldn't use equal NA for obvious reasons. So yes, no. I think I was the guilty one of that Batman joke. So a long time ago. So you can blame me. And so you should use is NA. You have multiple oops. So obviously, because you have multiple types, you also have multiple NA type, in fact, and you can specify them. One of the reason I think it's because for higher order function, and sometimes you want to specify the type, but you also want to return NA. Oh, testing. So you can test every type of vector with this function. It is as the type. The one that I totally don't like is this 3, and particularly is numeric. So yes, read the doc, I had them. Coercion, R follow the basic rule of coercion, like, and basically like it will convert logical to logical to integers, integer to double and double to characters. I think you have that in plenty of language. It does that automatically, which can be dangerous. And explicitly, you can use like specific function. Let's see a bit some example by combination. So I think this one is pretty safe, at least in my mind, but I could be wrong. So in this case, it's gonna convert every true is gonna be logical. It's gonna be characters. You can convert by mathematical operation. This one is used frequently, using true as 1 and false as 0. This one is used in plenty of cases, like especially in indexes. And then you can be explicit either with like the I think the R-long function or like the base R function. And it can fail, obviously, if you contain NA or some other stuff. I will not go too much into that. Exercise 1. Do you want to review the exercise, or is it some specific like you want to review? I think those one are fine, and we should go a bit at the end of the book, no? I mean, at the end of the chapter, which I think is more interesting. Yes, no?
Yep, we'll go end of the chapter.
Yeah, I agree. Anyway, you can review them on the slide when it's going to be pushed. This one always this one always trick me, so you should review it.
1 second, like you said that I can review it. Like, does it run automatically here?
No, it's in my Cohort. I have submitted it, but John didn't have time because I was late to
the slides are always available at there.
Yeah,
no,
yeah.
I was thinking of WebLive, like must have used WebLive so that we can run it right here. So that's what I was thinking. Never mind.
Okay.
Yeah.
I couldn't hear you well.
Not yet. We don't have a reason for that yet.
Yeah, I was okay.
Okay. Yes, I don't want to do that, but yeah. Okay, attribute. This is super important. You can provide metadata to vectors by providing them attributes, and R, abuse, and superuse all of that. So attributes have a name and a value, and they are using as a metadata. And that's kind of dangerous sometimes because you can lose them. So they can be set, I think, either like by retrieve and modify. I will have example later with attribute, attr, which is not the same as attribute, which will return all of them. And you can also, like with attributes, have an argument that specify by name, get the correct value of the pair. And you can set up en masse with structures kind of similar in other languages. Single attribute, this is an example. You have R, and then you can attribute R with attribute name, and then you, it's kind of, this function is, I never remember the kind of name of function, but then you can pass some attributes, and then you get back with attribute name, and it returns some attributes. Yeah, I should maybe change here to make it more obvious. So here, attribute name is the key in some way, and the value is some attributes. Multiple attributes, and we're gonna see some example of why we do that. Is sometimes you want to have vectors that have multiple, we get plenty of example of why you want to do that. Other example with structure, I mean with attributes and the structures. Why? I mean, this is a part of it, but like sometimes you want, like, this is some specific attribute that R will treat particularly the name, a character vector giving each element a name, and we're gonna see some example with data frame and list. Dimension, this is used to describe and transform some vectors into matrices and arrays. Yeah, Go for it, Tata Fanny.
I was thinking just like the attribute, does it overwrite actual value or it would just have another copy of it?
Sorry, I couldn't hear you correctly.
No, like say you said you have, if you go to the previous slides,
Yes.
so you have an attribute A, X is actual value, and you're trying to write A, B, C, D, E, F to it, right?
Sorry, I can't hear you well. Let me give me 5 seconds because it's probably me. I never know that. Eh. Here, should hear you more now. Here, can you repeat then?
No, I mean, yeah, it's just that, like when you assign an attribute, right? How does the value change? Basically before, before you do not have any attributes, what would be the value of it? Value of A is 1, 2, 3, right?
Yeah, A is 1, 2, 3, and then this is the key of the attribute, and this is the value that it's gonna take. I never remember the name of this kind of function. When a function is a setting function. I think it's a setting function, no? So basically, like this is it's a special syntax. Let me and maybe someone can correct me. Let's go. Do you see my shell?
Yes.
So I think basically what we have is this should be something like that. This is a setting function, and it's like 2 parameters, the attributes of A, the X, and the second argument should be ABC. D, E, F. I have not done define X A, so it's probably not gonna work. A also. A. Sorry, A, I know define A. Oh, no, X. Dang, I'm stupid. A. So this is similar. So I think I mean, if I understand your question correctly, this is basically using this attribute A, I mean, this line 2 is the same as what I have typed here. It's just like the R way of writing that function. That was that your question?
No, basically I was looking at where does it store this value of A, B, C, D, E, F? And if it is storing somewhere, right? Is that going to be temporary or permanent one?
Yeah, it's temporary.
Those kind of, I'm looking at those kind of like in that way, but yeah.
And see, like you have like this, it's how it have been stored somewhere.
Yeah.
And if you write like that differently, see, you have another syntaxes, by the way. So it's probably not exactly the same.
I think I got my answer. Yeah, sure. I see how it is doing that. I mean, I could see the second 7, 8, 9 is replacing the same thing, so it is going to be done. That okay. So I got my answer.
It started as the list. X is the value we attributed. I mean, it's the key, and the value is the character name A, B, C, D, F, and Y is still the data. But here it's because like it's still not the data. It's still it's a string of attributes. Let's type everything.
It's cool. Like, can see, like, you can make something an attribute. And that thing was like another like object. So I could make a circular like reference. Almost. I'm not making.
I don't know if you can. Do you want to mean like to reference for example X to A? or create another one. Let's say Bob.
Yeah,
Letters
yeah, I mean Bob and Alex.
2.
And then yeah, like
And then do you want to attribute, let's go back to that.
and then an attribute of Bob could be A.
And do you want me to make this Y, for example?
Yeah,
And make it Bob,
yeah.
which does not like it. Because I think you can only, it can only take some,
What did you assign? You gotta go back to
because like this is 2 elements and it should be 1, no? Let's kill
Then
it.
should the Bob should be in the quotes?
Bob should be the attribute. But it's interesting is the attributes are a list, and we learned last week that each element of a list is a reference. So you can have like kind
Yes.
of fun circular references.
Let's see if Bob is A. This is, I mean, no, Bob cannot be A. What should I do?
Check what is A now?
A is 1, 2, 3. With an attribute X that's tagged A, B, C, D, E, F.
Yeah, you can make an attribute of I. And I think it's still assigned to Bob. I think before you had a better type.
Couldn't hear you correctly, sorry.
Um,
Yeah,
I don't know, I'll put it in the chat. And see.
cool. Let me open the chat. Yes, it should work, no?
Should work.
But Bob, it's still ABC, no? Should I read? Bob is 80 right now.
Yeah, that should be fine.
Okay.
Other thing too is the strings. It's kind of referencing the string.
Because it does not like.
Oh, those yeah, backspace. Those are quotes because they're not like actual like.
Yeah. This is Zoom quotes.
Yeah, and then to the other one, and then it should work.
Works. And then if I do str A. Yep.
Yeah, which is interesting.
So it's characters of length 2 and it's AB.
Yeah, that's cool. Yeah. And then I'm wondering that the memory address would probably.
do I have upstairs?
Yeah, I think they'll be like sort of shared.
No, like let's see if I have it first. Like that. Never remember. Oops. So
Yeah. I know we get on the tangent. We don't have to go down this tangent.
okay. While it's doing that, I'm gonna continue. We have seen that. So you can set up name in plenty of ways, either when you create the vectors, either when you can assign it after, which is another, I think, assignment function is maybe the name. And you can also use set name. The first way is using Erlang, which go that way. And it's an assignment like, yeah, this is the simplified version of it. If you go into the book, you can remove name by 2 ways, either like you unname it, which do basically like provide null to the name, and that's reset the attributes. I can like, if I go here, it install lobsters. So library. Lobsters. And what did you remember the function in lobsters that check the memory addresses? I don't remember. Anyway, we still should have ls. We still should have a. So if we do so structures a, and if we do attributes a x equal, take the value null and it's remove it. Okay. I have never tried Haven, so I don't know. You can set up some dimension. I will not go too much into it. The trick is like you should always, I mean, so far the hardest part for me, and an array is multiple dimensions. So like the third number here, 4, is just gonna be the number of array you set up. You have multiple functions to work with vectors, matrix, and array. You need to be caution. So Hadley recommend not to use row name, but use row that name and row that and call that name. I don't know why, but this is what is supposed. And transpose can also be used. I mean, we're going to see that letters, and you can permit an array also. Function to work with vectors and matrix and array. They are similar. I'm not gonna go it. Or is set name implemented or is unname implemented? You just use attribute in ATGR. I mean, do you want to see some exercise or should I go? Because we are still not having seen the table.
Go ahead.
Okay. So, and we're gonna see a small example. As 3 atomic vectors is one way of having a specific class attribute that have some specific, so you can use that to pass it to generic function that's going to dispatch to a specific function related to the class. And the example we're going to see are the factors, for example, just after that. I went, and you will have chapters on S3, letters on the book. But basically, like when you have a specific object for, I mean, a specific object that have a specific that have an attribute type, let's say data frame of table or factors, some generic function, for example, print, will print the specific method associated with the class. Tadavani, you're still raising your hand. Should I? Is it good?
No, I reduced it. I mean, I downdated it, but sorry.
Okay. What's idea that I have not mentioned on the attribute is like you can easily lose them except the specific attribute we mentioned. So if, for example, let's see, so A to 1, let's call it Bill. No structures. STR, I don't know why. We lose the attributes above that we specified. So that's something like you should keep in mind. So example of S3 vectors that use in base are vector, that time, and duration, which is factors is a vector used to store categorical data containing predefined values. It has the class factors and it has attributes, specific attributes that's level that store all the level match the integers. And you have some example here. And or you can create one, you can build a factor using the factor function. It takes the colors and it's lists all the various level. And then you can use function like stable that are good on factors. And if you type of factors, which is usually not intuitive. It's in integers because it store it as an integers.
Mhm.
You can specify custom. You can specify specific orders for it, which is usually useful. Right now, it's not, so you don't see it. It's dates. Date are double vectors. Good example. I mean, you see it as like that. If I do a sysdates on my computer. Let's do that instead, because like it's paying me like it moved. Date, my date. Oh, it's my data. Okay, and if I do type of, oops, sorry, I get double, and if I in-class them, I'm gonna have, oops. It's giving me like the raw numbers that's used to build the dates system. That use the Unix epoch, and you can experiment with that by knowing like the Unix epoch is in the 70s, the first Januaries. There are two date time representation in base R, POSIX CT and POSIX LT. I can't pronounce that correctly, so I apologize. Oh, sorry, went back. And then you basically like you build them usually with a time zone. If you don't build them with a time zone, I think R will assume your local time zone. I mean, what it stores. And it's built on top of an atomic double. Duration, let's build this example because I think this one become tricky. Copy. Will I be able to system? If I do class of not dead time, I got a POSIX CT and POSIX T. Let's do state not time. Hopefully it's gonna work, but I'm not sure. Sorry, not underscores, not the great. Let's just correct that. Tick. No, sorry. And if I want to do a duration, you can use that. I have no idea of name of variable var1. Not minus, no, not that time, not 8. And it's a div time, and if I do a structure of it, you see it's as a full structures. And I can probably change the character, the units also. I don't remember. It's probably possible. Maybe when I how many times do you have? I think this one is easy. What happened to a factor when you modify its level? It's the pain. That's why people use the factors package. What does this code do? I don't want to do lists. So this was the weird part of the chapters, because like this is the smallest part, and I think list is fairly important. I don't know what you think about that, but Hadley went super fast on list. So I'm kind of curious what you think about that, because list is kind of the recursive version of the vectors. So this is a huge switch to say, but it went super fast. So basically, like it just mentioned, how you can construct a list. List can have multiple data type. This is what it shows here. You can also, like, you don't need to specify name, and it shows you how you can subset them, but we're gonna see that a bit more later in another chapter, so I didn't want to go too fast. You can also build nested lists, kind of like JSON. So lists, this is why lists are recursive and costly. You can combine them, and if you combine them into lists, it's gonna build a recursive list, but if you combine with C, it's gonna flatten them, which is not necessarily intuitive. You can test list with isLists or the long version. You can coerce them, but it's gonna generate multiple objects. Matrix and array, you can move from them to list, but it's not gonna work all the time. Okay, this one is a bit interesting, and maybe I will stop here to ask you what's the difference, because I went super fast. So what's the difference between a list and an atomic vectors? Instead of just me speaking.
An atomic vector is also a list.
Yep. An atomic vector is also a list.
Yeah, a list is basically a vector. I mean,
Yes. I mean, yes.
anything is a list in the R, right? If I'm not wrong.
I don't think a vector is a list. That's a good question. Let's see. A still want to no. Let's just create a clean A. Maybe I'm wrong. Is list A false? So I think if we go back, we build list with vectors. Where is it? No, we don't have them somewhere. My understanding is list is built on top of vectors. So you do a vector is not a list, but I think the reverse is not true. I went too fast. Oh, here. See the list reference to a vectors. This was here.
Okay.
So if I do, let's go back to my
So every list is a vector, but not every vector is a list.
I couldn't hear you correctly, sorry.
No, like the picture that you showed, right? Vectors or lists, and lists is broken down into two different
Where
things.
is that pictures?
So we can say every list, yeah, every vector is a list.
I think
every list is a vector. Sorry, my bad. Every list is a vector.
every list is a vectors. I don't think so. What do you think? What other things about that? I mean, every list must. I mean, yes, in some way, but for some reasons. Oh, every list is a vector. I got you. So if I do is vectors, I mean, let's build a list. Team. Should make a list sometimes.
Every list is a vector, but it's the list type of vector.
Yep. 1, 2, 3. Is it good? So is vector, Alice? This is what we want to test? True, you're correct. This was what you...
An expression is also a vector, which ours.
Yes.
Wow.
Probably some expression, no? I don't know. I think it's XPR. Oops. I close it. Sure. An expression is also I don't know if that's gonna work. Expression. I think it's XPR for expression. I don't remember.
True or false is a vector, right?
Could not find the expression.
EXPR is a R-lang function.
Expression bill. So is vectors. True. So an expression is also vectors. That's what. Data frame. So yes, I think the switch like from list is very fast, and then we move to data frame, which I think yes. I mean, I'm not saying like data frame. I think it's probably one of the most important structures, but it's a complicated structures if you compare to vectors or even lists. So it's a named list of vectors. It has multiple attributes. One is the name for the column. It has raw name, but Hadley strongly advised to not rely on it for a good reason, because he thinks metadata should be stored as data as much as you can. And it has the class data frame. I mean, I'm pretty sure everyone have built data frame. And it's give like, or you can access them. I don't remember the difference between n row capitalize and n col capitalize. I think the capitalized version is safer, but I don't remember exactly why. The difference between table is like they are summarized by they are lazy. They do less than the table, and they are surely when something break, they are like sending you error message. So lazy. Table do not coerce string, so they don't change it. That does not transform non-syntactic name into syntactic name. What could be an example? I don't think you can start a name with, I don't remember, like you were in the chapter previously. So let's say a non-syntactic name, it's going to be converted to a syntactic name. And if you want to avoid that, you should use like some backwards. Recycle vectors of length greater than 1. I think everyone have love-hate relationship with that one. Personally, I like it because it makes building fake data very fast, but it can be dangerous sometimes. So it does not coerce strings. This is an example.
So what does it do, the recycling thing of length? Can you explain that, please? Yeah, recycling vectors of length greater than 1.
Sure. Let's say let's build a data frame. So GF is a data frame. I'm looking at the time. A it's gonna be 1 and 3, and B is gonna be Alice. And R has no problem with that. And if you look at DF, it's gonna recycle Alice 3 times. And let's see if that works. I'm not a huge table fan, but I think this is a table, no? No. So the function to generate a table is table. Sure, I need to load it.
Table.
TBL.
No, table, right?
Let's see. If I'm wrong, it's gonna complain. Oops.
As table.
No, it's not complaining. I don't know why. Oh, I know. Combine. I misunderstood it. Team. Yeah, I got an error, which is good. And here, I also have an error, so I don't know. Any idea? So let's go. Let's see. Maybe we're gonna. I went fast on that. So data frame are recycling vectors, sure. Let's see. Well, do we have an example on that? No, I don't think so. So I have no idea to look after because I want to go a bit faster.
I think
Cohort string, we have seen that. Transforming non-syntactic name, this is the one, the example with the one with backtick. And CR has transformed it with a X1 here. This is a classic. Oops. Here. While the table have kept the one. Recycling vectors. This is why here. I mean, let's see the example, but I think it's. So this is the one that we should have an error that I didn't have an error. So 2 is a copy. We have an error on the data frame. I don't know why my example does not work.
Hmm.
I mean, it's obviously named T-balls, badly named, but I don't know why. Maybe there's something because I used one. Yeah, it was just one, and it could
Yeah.
recycle.
Yeah, Tibble recycles length 1. It just doesn't
But not
recycle other
length 2.
lengths.
Well, we can.
The length 1, it assumes that you want it to be the same throughout the whole table.
Okay.
Otherwise, it doesn't recycle.
So that's it. So that's what we figured out.
Yeah. And
So
then it needs to be like even, like if you do 1 to 5 and 1 to 2, even data frame freaks out at that.
yeah, we saw that, I think,
Yeah.
here.
Okay. Yeah.
Okay. Subsetting always yield a table. Here, this is where like you should all remember that when you subset, you can have the argument drop equal false. So you avoid like, let's go back here. Table, it's a data frame here. If I do table subsetting 1, I guess, it return no, maybe a class. It's return a numeric, and type of it should return integer a double, but it's a double, yeah. But if I do drop equal, okay, I'm gonna be lazy. It's keep it as class. It's gonna be a data frame. And table always have this. I mean, have the drop false behaviors all the time. If you cannot find the column, I don't remember what data frame do when you do that. Oh yes. So here, data frame will be too smart for you. So it's gonna assume like what you want is call 1, which table does not want, and I think this is a better choice. That's something cool. Table allow you to refer to variable created when construction. This is a good example. X does not exist, and you use it on the line 3 to create something new. Table are sometimes nicer printing. I guess it's a depend of taste. We have seen the table subsetting. I have like table testing, so you can test them like for is data frame and is table. You can coerce one from them. Usually it's safe. Table, but also data frame can have, I think data frame can have like, does data frame can have list column? I don't remember. But you can do that, and I think at least for table it's used in, I mean, having list as a possible option inside of the colon is very useful. Especially like, for example, in my field in spatial data, where you want the geometry column storing coordinates. So usually like list of elements. You can also, as long as it's possible, convert from one to others. This one is funny. Does someone have any idea?
Yes. I think so.
So this is super easy. It creates something. I don't know what to do with this kind of object, but it works.
No, like if you go back, that's a very interesting concept. Basically in the SAS world, I mean, because I always refer to my programming language, if say something of a proc freak has nothing in it, it produces an empty data set out, and we try to use it by capturing the length of basically the contents of it, and then say that it is missing or doing something.
I mean, the length's gonna probably, sorry.
I mean, like I'm trying to see how can we find out if
it's 0.
okay.
It's still in the that some function can take, apparently. Let's see something a bit worse. Well, it's also 0.
That's
but that could, I mean, yeah, okay. No comments. That could be tricky. So row name should be unique. This is something very specific. Hadley spent a long time discussing that. So you should just read the discussion. I mean, and we can discuss it. I think because like a data frame is something very complicated. I think row name was used also like to build some kind of indexes and allow like some fast processing, which is not necessarily the case if you consider that a data frame is basically like a list of I wrote it. It's a list of structured data. So it's a recursive or structured type of data. So it's kind of hard to process. And I think there's a lot of implementation around the row to be faster while processing it. But I don't know if they were successful. You can easily transpose, which is work in some cases or not. This one was tricky. Let's review it, maybe. It will convert, it will coerce, basically. Oops, not the other one. So we can like, I mean, I just have 4 minutes, so I want to have a bit of talk. Null are special, we already discussed them a bit. They are used to reset some, they can also use to reset some column, by the way, because column are vectors. And oops, digestive, that was a lot. We have seen a lot of stuff. We can explore them also with the penguin, the printing, the atomic vectors, the column name. I'm gonna go fast. So the quiz, and now like hopefully you can help me. What are the 4 common type of atomic vectors? They are easy, and the 2 they are a bit harder, but
character, double, integer.
this one that is easy, that's bad. So I think like, so it's characters, integers, double, and logical. I don't know if there are all of them, but let's see. And the complex are the other one are complex and raw, and you can generate raw with car2 raw and stuff like that. What are the attributes and how do you get and set them? I think attribute, can some others and not me like do it? Okay. Yes. Okay, you can, attributes are basically metadata that you store on top of the vectors. And it can also on top of other objects. Our list is different. We already have discussed that. I mean, we didn't have discussed how the matrix is different from a data frame. But the matrix is just a vectors split by dimension. So it's not a recursive element with different data type. It's only one data type by definition because it's just a vector. Can you have a list that is a matrix? Probably if there are only one data frame. I don't know. That's a good question. You can, but it's, yeah, you need. Yes. Wow, that's dangerous. But I see the usefulness. How do table behave differently from data frame? They are surely and lazy. We basically like they don't do a coercing name. They don't they not allow recycling in some more when it's not one, and I missed the third one. And that's it. So you have the floor, question, remark. I went super fast. It's
Yeah, thank you.
Thank you. Maybe you have to say end.